Hello and welcome to another lesson from Simply PE, this time in the topic of muscles in action. So a reminder with these presentations, the yellow text boxes are the tasks for students, the green text boxes are the note-taking sections for students, the blue text boxes are differentiation tasks, and the red text boxes are teaching and learning strategies and ideas for the practitioner. So in regards to this specific topic, the syllabus requires you to know how muscles work in pairs and this concept, this idea of antagonistic muscle action. Okay, so we're going to look at that specifically. We then need to understand the different type of muscle contractions for movement. So we're going to look specifically at two different muscle contractions and for the syllabus, and then finally applying these contractions to sporting examples. So without further ado, let's get going. So first and foremost, antagonistic muscle action. Okay, so what do I mean by this? So remember, and I'm always going to constantly say this when we talk about muscles can only contract, and you've probably heard that word before in terms of contraction. And when we talk about muscle contraction, what we mean by that is the muscle tenses, okay? And muscles can only pull, and they can only pull on the bones that they're attached to, okay? So we need to be aware of that as well in terms of thinking about the movement and the muscles working in pairs. So in essence, joints require at least two or more muscles working, and they need to be opposite each other, okay? So while one muscle works, the other relaxes, and we'll look at that more specifically in this example in a second. And as I said there, so these muscles, they work in pairs. So as one contracts, the other relaxes, and then we go back to the original movement, the other muscle contracts and the other one relaxes. So this is known as antagonistic muscle action. Okay, so we really need to be aware of that key concept when we talk about muscles working in pairs. And more specifically, we need to know these two specific examples. An antagonist or an agonist, okay, is referred to as the prime mover. Okay, so the prime movement, the prime mover, the muscle that causes that movement. And the antagonist is the muscle that relaxes during that specific movement. Okay, and this allows the agonist to contract. So let's look at this in a bit more detail with this example on the right hand side. So here you can see quite clearly a bicep curl. Okay, so us clenching our fists, and you can just do this when you're sat watching this presentation, okay, and when you clench your fist and you do that bicep curl where you bring your forearm towards your shoulder, okay, and then move it back again towards the ground, okay, that is referred to as a bicep curl, going up and then going down. Okay, so in that flexion phase where we're bringing our forearm towards our shoulder, our hand towards our shoulder, okay, what's happening there is the bicep is contracting. Okay, so what we mean by that is the bicep is tensing, it's shortening in length, okay, and then the tricep, which is found at the bottom part of our upper arm, okay, as you can see on the diagram, during that flexion phase, it relaxes, okay, and then when we bring the hand back towards the ground, okay, and we extend the extension phase, then the opposite is happening. The tricep is now contracting and the bicep is relaxing. So your first task is thinking about this question here. So which muscle is the agonist and antagonist in each phase? Okay, so hopefully you've answered that question. So remember, when we're looking at that flexion phase, okay, so bringing our hand up towards our shoulder, that bicep curl in that flexion phase, okay, the bicep is the agonist, okay, and the antagonist, the tricep, is relaxing, okay, and then in the extension phase, it's a role reverse, okay, so the tricep is now being the agonist and the antagonist is now being the bicep. Okay, so let's look at this in action, and you can actually see a bicep curl here in this diagram on the right hand side. Let's look at the first muscle contraction that we need to know about, and it's called isotonic contraction. Okay, the way I'd remember this is if you think about tonic water, okay, that carbonated kind of drink, it contains some sugar, and basically sugar gives us energy, and we need energy to move. And when we think of an isotonic contraction, we're thinking about a contraction where the muscle changes in length as it tenses, as it contracts, and ultimately it causes movement of the body. Okay, so you can see in that bicep curl that the guy's doing on the right hand side of this presentation, okay, there's movement occurring as the bicep contracts, bringing the weight towards his shoulder, okay, and the tricep is relaxing during that flexion stage, and as he extends his arm and brings the weight back towards his hips, okay, then obviously the tricep is then contracting and the bicep is relaxing. Okay, so this is isotonic. There's movement which is occurring during that muscle contraction. Pause your video here. Can you think of any other examples, okay, of this type of muscle contraction? Okay, so this is obviously a common form of muscle contraction. If we think of abduction, so moving our arms away from our body, okay, the deltoid is contracting. Okay, that would be referred to as an isotonic movement because there's movement as you take your arm away from your body. Okay, we think of our legs. Okay, if we draw upon kicking a ball, for example, we flex our foot back, don't we? Okay, before we strike the ball, and then we extend our leg with that extension phase, okay, where we look to strike the ball as well. Okay, so loads of examples here of where there is movement occurring. The second muscle contraction that we need to know about is isometric, okay, and during this contraction the muscle remains the same length, okay, so it's still working but there's no movement occurring. Unlike in isotonic where there is no movement occurring at all. So muscles contract, but there's no movement. And you can see on the right-hand side, the gymnast in the crucifix position and the woman in the plank position. Okay, the abdominals are contracting, they're working during that plank phase. Okay, as well as the deltoids will be working, as well as the latimus dorsi will be contracting and working during that crucifixion position of the gymnast. But there's no movement as such. Okay, so that's isometric contraction. Again, pause your video here. Can you think of any other sporting examples for this type of contraction? Other examples you might have come up with, think of a wall sit, for example, okay? You'd be working the quadriceps, okay? So you'd sit into that squat position against the wall, okay? And you should eventually start to feel the burn on your quadriceps because they're contracting, but there's no movement as such, okay, when we're sat against the wall in that specific position. Other things you could have talked about is tug of war, for example. If there's an equal pullage on both ends and there's no movement, that is an example of isometric, as well as obviously a rugby scrum. If the same amount of force is being applied to it and there's no movement either way, then obviously that would be isometric as well. Okay, and then looking back at isotonic, so if we look back at that key concept of isotonic where there was movement, if you remember, within this muscle contraction we need to know about two other specific type of contractions, and these are called concentric and eccentric. So when we look at concentric, okay, within the isotonic contraction, this is where the muscle shortens. So remember, in that bicep curl phase, okay, during the flexion phase, okay, this would be an example of the bicep being in the concentric phase because the muscle is shortening in length. The bicep is shortening in length. But when we bring the weight back in the extension phase, okay, again, if we're specifically looking at the bicep here, then that would be referred to as the eccentric contraction. Okay, so here we can see the bicep lengthening. Although it's relaxing, okay, it's lengthening, okay, and that would be referred to as the eccentric phase. Okay, so it should take you a while to get your head around this, but just think back, just look back at that muscle movement. Okay, concentric is where that muscle shortens in length. Eccentric is where that muscle movement and the movement occurs in terms of the body action movement occurring, but ultimately here you can see the muscle lengthening, and that would be referred to as eccentric contraction. Again, pause your video here. Again, can you think of any other examples of concentric and eccentric? Other examples you could have come up with, again, if we look at the flexion and extension at the knee joint, okay, we've got, for example, when we flex, okay, we're working our hamstring, okay, and ultimately that is the concentric phase. And then when we extend our leg to actually connect with the ball, okay, the eccentric phase of that hamstring, okay, when it's relaxing, it's increasing its length, isn't it? Okay, so ultimately the hamstring would be the eccentric phase there during that extension. Okay, let's finish off with a few exam practice questions. So there are 2 questions here for you. I'm not going to talk through them, but pause the video here, have a read through both questions and see if you can answer it. Question 7 is worth 2 marks and question 10 worth 3 marks. Okay, so hopefully you've looked at both questions, you've tried to answer them. So let's focus on question 7 first. We've got Usain Bolt driving out of the blocks, okay, and specifically it's asking for the agonist at the knee and the ankle. Okay, so we need to identify which muscle is contracting, is the prime mover, okay. So let's look at that answer then, shall we, in terms of question 7. Okay, use a green pen if you need to add anything to your answers or if you need to tick off what you've written down. So first and foremost, if we look at the answer, okay, when we look at the knee joint, okay, during the agonist within the knee joint driving through the blocks there, that would be the quadricep, okay? So ultimately the quadricep is the agonist there, the one that's contracting, okay, as he kind of powers out of the blocks. And within the ankle, okay, we can see the agonist there, okay, and it's a movement, isn't it? Movement type of, as well, I won't mention it just yet because that's an extension task, but it's the gastrocnemius, okay? So the calf muscle, you can see there, the gastrocnemius at the back of the leg, okay, where the actual arrow is pointing towards, okay, that is the one that's contracting. So can you explain why, just as a differentiation, a challenge task, can you explain why? Pause the video here, see if you can expand on that. Okay, so if you think of the knee joint first and foremost, okay, what's happening here is extension is occurring because the angle of the knee joint is increasing, okay? He's obviously coming out of the blocks, he's coming out of that flexion kind of position where he's in the starting blocks and he's now kind of trying to increase that angle, okay, and that his legs are straightening, okay. So we can see there then that means the quadricep is contracting. And try and do it yourself. If you're sitting down at the moment, as you straighten your leg, you should be able to feel that quadricep tightening, okay. It's tensing, it's contracting. That's what's working at the moment, okay, and that'll be what would be working for Usain Bolt there at the moment. And ultimately, while that happens, the hamstring, so at the back of his thigh, okay, that would be relaxing because remember, muscles work in pairs. And then if we think of the ankle joint, what's happening here is during the toes, okay, the foot, that's kind of pointing and driving down towards the ground. That's where he's trying to get his power from as he bursts out the blocks. So what's happening here is the movement type that's occurring is plantar flexion. Okay, and ultimately as those toes and as that foot drives down towards the blocks, okay, again, try and do it when you're sat down now as well. If you sort of point your toes down to the floor, okay, that movement of plantar flexion, you should be able to feel the back of your lower leg, your gastrocnemius, that is what's tightening, that's what's contracting, okay? So again, the answers are actually within your own body, okay? All you need to do is kind of just play around, just move around with your body a little bit in terms of trying to figure out what's contracting and what's relaxing. So there, what's contracting is the gastrocnemius and ultimately the tibialis anterior, as that works in the pair with the gastrocnemius, that's obviously therefore relaxing. And then finally into the second part of the question, question 10, okay, pause the video here. These are the things that you could have talked about for 5 marks, okay? So the bicep is the agonist, it's the prime mover, okay, which contracts, it shortens to cause the movement from position A to position B. You could have mentioned that the biceps are attached to bones in the lower arm in particular, or most, even more specifically than that, you could have said the radius bone, and that's obviously via tendons, okay, and it goes on, okay? So look through those bullet points to help you to answer that last part of the question. And then finally, for the teaching and learning strategies, teachers, make sure you go through some scenarios with the students so that they can explore their own sort of bodies in terms of the muscle groups and the movements that occur. Okay, use pictures and demonstrations. So again, get students out in front or working in pairs to see the movement types that can occur within the specific joints, and make sure you use plenty of application. Okay, so examples from lots of different sports. Best of luck.